Hi everyone, a very good morning to all of you. Now we are going to study the 41 question that is related to self and mutual inductance. It's all about what is self and mutual inductance. So when we consider this, the very first thing what we have to understand is self inductance. So what is the meaning of self induction? Self induction nothing but inducing EMF and current in a coil due to its own current. Due to its own current. Like if there is a coil and current I is there, I increasing or decreasing. Then the magnetic field due to that current increases or decreases, then magnetic flux linked with that changes due to its own current. Then there is a back EMF and that phenomena we call it as self-induction. And the EMF induced called self-induced EMF and the self-induction current. Now the parameter which comes in this phenomena is called self-inductance. Similarly, the definition of mutual induction is when there are out of two coils flux linked with a coil depends on current in other coil. That means inducing EMF in a coil due to adjacent coil. So inducing EMF in a coil due to adjacent coil. Just like here one coil, or one coil is inside the other one. Like that, where there is a current in one coil, then there is a magnetic flux linked with other coil. Now when this current changes in one coil, the flux linked with other coil changes. Like one we call it as primary and the other one we call it as secondary. So due to that mutual interaction, whatever current will induce in the secondary coil, and that phenomena we call it as mutual induction, and that parameter is called mutual inductance. Now, in case of self-induction and in case of mutual induction, when you consider here flux linked with a coil is directly proportional to its own current. Here flux linked with secondary coil is directly proportional to current in primary coil. And here the proportionality constant L. Here the proportionality constant is M and L is called self-inductance and M is called mutual inductance. And the EMF induced in a coil is minus L di by dt and here minus M di by dt. And in case of a single coil, in a coil, the magnetic energy stored is half Li square in the self-induction process. Now based on these things, the question can come. So like here, what is the energy stored in an inductor? Means when there is a coil and the current grown from 0 to I, then work done or energy stored is half Li square. L is inductance, I is current. What is self and mutual inductance of a solenoid? In case of a solenoid, the self-inductance is mu naught N square A by L or mu naught N square A into L. Where small n is number of turns per unit length, capital N by L. And in case of two solenoids, one inside the other, the mutual inductance is mu naught N1 N2 A by L, or mu naught N1 N2 A into L. L is the length of both the solenoids and A is the area of inner solenoid. Sometimes they may also ask the combination, like, for example, I am telling, this is one small coil of radius R. This is one big coil of radius R. They place it like this. Then what you have to find is flux linked with inner coil. That should be equal to some constant into current, and that constant only we call it as mutual inductance, flux by current. Like there is a current in the outer coil, so the magnetic field is mu naught Ni by 2R at the center into area. Then that gives the mutual inductance of the two coils. One is smaller, one is bigger, like that. Now, see, here this solenoid and combination of solenoids is well-known one. Usually they'll ask questions. But sometimes they can give any combination, as I shown the example, and they can ask the mutual inductance of the system. Then you have to apply the procedure, like you have to imagine current in one coil such that there is a magnetic field on the other coil, and then you can find the magnetic flux. Then you can find the flux by current, that is nothing but self-inductance or mutual inductance. Now here, what inductance would be needed to store 1 kilowatt hour energy? So the energy is 1 kilowatt hour. Kilo means 10 power 3. Hour means 3600. So joules. In a coil carrying current, current is 200 ampere. So U equal to half L I square. They are asking inductance. So inductance equal to 2U by I square. So 2 into 3600 into 10 power 3 by I is 200 into 200. 0, 0, 0, 4 0. So 0, 0 cancel. Now 2 cancel. So what will come? 18 Henry. Now the next question is, two coils having self-inductances. The current in the coil is increasing at same rate at a certain instant, and the power supplied to the coil is also same. Find the ratio of induced voltage. So the induced voltage formula is minus L di by dt. Now current increasing is same, so that epsilon is proportional to L. Then epsilon 1 by epsilon 2 is L1 by L2, that is 5 by 1. So 5. Now current I equal to and the power supplied to the coil is also same. So power equal to epsilon into I. Then current equal to P by epsilon. So as power is same, I is inversely proportional to epsilon. So I1 by I2 equal to epsilon 2 by epsilon 1, that is 1 by 5. Now they are asking energy stored. So energy equal to half L I square. So the ratio U1 by U2 is L1 by L2 into I1 by I2 whole square. We have L1 by L2, that is 5 by 1. I1 by I2 is 1 by 5 whole square, that is 1 by 5. So this way, simple question they will ask based on the formulas whatever we have seen. Even though the question is big, the process is simple formula based. The only thing is you need to understand the question and you need to apply it properly. Now one more question is, if a current of 10 ampere changes in 1 second, so time 1 second and current changes by 10 ampere and the induced EMF is 10 volt, then the self-inductance F equal to L delta I by delta T. So L equal to epsilon delta T by delta I. So epsilon is 10, delta T is 1, delta I is 10. So the answer is 1 Henry. Now comes one more question. Calculate the mutual inductance between two coils when a current 2 ampere changes to 6 ampere. That means delta I is 4 ampere in a time of delta t 0.2 seconds and induced EMF is 20 milli means 10 power minus 3 volts. So epsilon equal to minus m di by dt implies mutual inductance is epsilon dt by di. So epsilon is 20 into 10 power minus 3. dt is 0.2 by di is 4. 4 5 are 5 into 0.2. 1. So 10 power minus 3 Henry. 1 milli Henry also you can write it. Now one last and final question. A straight solenoid has number of turns per centimeter. That means n value, small n value. How much? 50 turns per centimeter. So per centimeter means 10 power minus 2 per meter. And this is primary, sorry. And 200 turns in, N2 is 200. This is N1. Now, the area of the cross section of the solenoid is 4 centimeter square. Calculate the mutual inductance. So what is the mutual inductance of the coil formula? Mutual inductance means mu naught N1 N2 A by L. And here N1 by L value they are given. And mu naught value is 4 pi into 10 power minus 7. And N2 value given, area value given. So you substitute all the values, then you will get the mutual inductance. But here, realizing the data properly important and conversion of unit. 4 centimeter square is there. So 4 into 10 power minus 4 meter square. So you have to remember the constant value mu naught. Then the question becomes easy. So this is how they will ask the questions based on self and mutual inductance. So sometimes very rarely they'll ask the question based on combination of inductors like series parallel. Formulas are similar like resistors. Like in series connection L equal to L1 plus L2 and in parallel connection 1 by L equal to 1 by L1 plus 1 by L2. So please take care of all such questions and practice well. I have given the assignment questions similar. So please just try to solve all the questions. And I also have given the NCRT based questions. If 4 questions are there, simple questions, then you can understand the kind of question they can ask. So thank you all of you. We'll continue in the next session with next lecture. Thank you.